Windsurf, of course, for starting a revolution. Dame Stephanie and Master Graham, who had the vision. Bill Dutton, who translated it into reality. And congratulations to all the others who made this the top social science research center on the internet. Hats off to all of you. But guys, what will you do for us next? This gets me to my topic, the future of internet policy research. Now, you must understand that policy researchers are only happy when they are unhappy. They are dependent on problems and crises in the way that addicts need a daily fix. Try to get an article published, or tenure, whose theme is, "Things are great on the internet, thank you government, stay the course." The incentives are much more for articles on the type of woe unto us. Which is why, as an economist, I note with chagrin that policy research has snatched from us the distinction of being the truly dismal science. To all of you policy researchers here, I bring you, therefore, good news. Our problems have just begun. Now, it is important to understand the fundamental facts, the general direction where things are going, or else we will be like those communications professors who still write about, or at least think about, the 3 television networks. We have gone through the kilobit stage of the internet, kilobits per second, ISDN with its scorching 64 kilobits per second, and it was still derided by serious academics as the acronym for innovations subscribers don't really need. Today, we are in the megabit stage. And to many, again, this is the end of the story. But it isn't. We are just entering the gigabit stage. Network speed 1,000 times as fast as today, or 1,000 times cheaper than today per unit, or a combination of both. Speed, of course, is a misnomer, but everybody else uses it, so I know. What have been the broad trends? If I could, I would have shown you a chart from a study by Christopher McGee at MIT that shows an exponential growth in network transmission speeds over 150 years. For the period starting in 1850, the trend of increase in network speeds has been 19% per year for 150, 160 years. And it shows an acceleration now to about 40% a few years ago and probably 50% now. Now, this is the trend of technology of pipes, not necessarily of its economics. We've had airplanes flying at a speed of over 3 times the speed of sounds for decades. They cross the Atlantic faster than it takes to get through Heathrow Airport security. But they are not economical for moving passengers. Same for automobiles. These technologies have an increasing marginal cost per unit of performance. But for information transport, it is the opposite. Average cost keeps declining, with a compound annual drop of 13% over 135 years and accelerating. That's research we've done at Columbia. These are broad trends of over a century and more, and there's no reason to assume that they will somehow end abruptly or somehow slow considerably. The transmission technology of fiber in particular still has a huge headroom to grow. So where will this go next? The skeptics believe that on the internet we have enough at maybe 10 megabits per second, but they don't do the math. They think we have enough, nobody needs any more. But let's do a back of the envelope calculation. An HD quality television transmission has about 2 million pixels, 3 primary colors for each pixel, 8 bits per color, 60 frames per second, 3 channels per household, or for multitaskers. This means that such HD TV internet requires about 10 gigabits per second, not 10 megabits per second. Compression will reduce this, of course, maybe by a factor of 100, which is pretty optimistic, and one can also reduce the frame rate. So you can bring this down to maybe 50 megabits per second, but at the expense of quality and latency, which is important for games. And this is not the end of speed requirements at all. Television screens become flatter, cheaper, and larger, while apartment sizes stay the same, more or less. Therefore, the pixel density will have to grow in order to maintain sharpness. That's just a combination of optics and biology. The next generation of television resolution is 4K. If we do more bit arithmetic, we find that this would require about 130 gigabits per second just for a household. And on top of that, this will not be obviously your grandfather's television, so it would require three-dimensionality, which would require doubling, two-way interactivity, which would require another doubling, superior audio quality, it requires still more bandwidth. If you add all this up, you find a transmission requirement of about 600 gigabits per second, more than half of a terabit. This is kind of an extraordinary number and clearly far, far from what we have today. Now, all this does not even include a television of immersion, a futuristic type TV, which would surround the viewer. Such television would permit a viewer to participate like a game player or a user of virtual worlds in the visual action and act inside the imagery. Such kind of television is a logical extension of video games, and it is entirely predictable and I would say inevitable. In terms of bit requirement, this would still require about 10 terabits per second. So there is a lot of place to go. Obviously, all these numbers will be squeezed by compression and other techniques, but it is the reference point, the gold standard, from which engineering must artfully whittle bits away to fit a narrower channel. MPEG-2 compression ratios today about 15 to 30. MPEG-4 compression ratios are about 50, and compression, as I mentioned, reduces quality, has other problems, but even if we compress and reduce bandwidth by a high factor of 100, one would still require at least 6 gigabits per second per household, 6 gigabits per second, 1,000 times as much as today. Now, from today's perspective, this might not be there might be no imminent consumer demand, but that's what people also said when color television supplanted black and white. Why do we need all that color stuff there? Or when HD TV doubled the 525 or 625 lines of standard television, or when DVD replaced VCR cassette quality, or when cable television introduced 12 channels instead of the 4 or 5 over-the-air signals. Users get used to higher quality and quantity almost immediately, and they never go back. This trajectory has implications for policy and for policy research. Take, for example, a question that is bandied about around the world, the question of wireless broadband. Around the world, governments have been pushing national broadband plans that include a strong component of mobile wireless, 4G, LTE, that stuff. The problem is that people, in assessing this as the future, particularly for poorer regions or countries, that people have been listening to those up to speed projections in the press that in turn have been generated by corporate PR machines. Let's see if we do another simple back-of-the-envelope calculation. Suppose we do succeed in liberating for 4G spectrum totaling 300 national megahertz. Each site would use 1/6 of these frequencies without interfering with neighboring cell sites. There would have to be duplex in each direction, and if you take 2 bits per second for each hertz, you get a two-way pipe of 50 megabits per second, and this pipe would be not just for one company, but it would share by all the carriers operating in that particular area of that cell site, and it would also be shared by all the users. Therefore, any time that more than 10 people try to use the cell site at the same time, average speeds would drop below 5 megabits per second. And of course, more than 10 people would use the cell site if it is the only or main connectivity to the internet, or if they want to use it for video purposes at the same time. In the United States, a cell site typically has about 1,000 people, although not all at the same time. And the only way to counteract this would be either to get much more spectrum, which is politically really difficult and expensive, or by constructing large number of additional cell sites. But even if there were a cell site for each single user, which would be incredible and uneconomic, the speed would be only 50 megabits per second. This is not a matter of better engineering, it's physics. Now, thus mobile wireless is not going to catch up with wireline. It's important that I'm saying mobile, because if you have focused wireless, microwave type wireless, that's a different story. But the mobile wireless, as much as technical progress as it is making, it has not been gaining, relatively speaking, on wireline. There seems to be always 100 times fast, which always seems to be 100 times as fast. And secondly, there are the economics. The problem with wireless is that it has negative economies of speed, while wireline has positive ones. If you double network speed for wireless, you need more spectrum and additional cell site, and these become more expensive while serving fewer people. This means that it makes no economic sense for mobile wireless to be substitute for high-speed wireline when it comes to fixed locations, such as homes and offices. It would be a waste of scarce spectrum. 4G wireless has its unique uses in mobile and nomadic applications, or in highly inaccessible areas where people would accept a lower speed. So the policy question is, would rural folks accept for long the 4G mobile communications as their broadband platform at a lower speed, higher price, and less openness? You guess. At first, of course, they would be enthusiastic of the improvement, welcome it with open arms, but soon the reality of a second-grade quality of connectivity will sink in. We should not expect rural areas to sit by and folks to sit on their kind of couch and squint into their little wireless screens and tablets while their metropolitan brethren enjoy two-way, 3D, 4K, 5.1 sound, 6-foot screen television. And they will organize political pressure. So this is one policy analysis. It seems pretty obvious to me, at least, but it contradicts government policy in dozens of countries, including the United States. Now, let me suggest a few other policy implications for policy research if one speeds up the internet by a factor of 1,000. One thing that is really important for us is we need to re-examine the basic premise of a lot of research, which is that the internet is fundamentally good and progressive, and that the constraints on the internet are the main problem. So we just need more internet and everything is going to take care of itself. We need to be more willing to deal with fundamental negatives, and not just that some people cannot afford the internet, or that there are some impressionable teenagers who commit havoc. For example, is a fast internet really good for democracy? Maybe for authoritarian places, surely for authoritarian places like Egypt or China, but probably it's the opposite for places like California or the United States, as witnessed by their heated up, hyped up, group fragmented, astroturfed, celebrity-driven, and super expensive politics. I've seen much less soul-searching about those trends, which are clearly being accelerated by the internet. I've seen much less critiques of that than I've seen self-congratulations about Tahrir Square. Now, extend this forward to a system where newspapers become secondary in shaping opinions on national issues, where most journalists have no home base, where political stories are mostly opinions competing with other strong opinions for attention, where the production of effective news presentation is actually becoming more expensive, quite expensive, because of rising user expectations as to quality, visuals, and special effects, and where journalism could become a production department of PR departments, of PR agencies. Or another issue, maybe we should address the question whether the internet is really green. Many people believe so. It seems almost kind of an axiom. But frankly, I have not seen the studies, and I have my doubts. So this is a research question, and the environmental aspects and impacts of the internet are likely to be a bigger policy research topic in the future. Or macroeconomic impacts. Take e-money and m-money. How do they affect economic stability? Imagine stability and the ability of governments to conduct monetary policy. Imagine a future where everyone is engaged in pre-programmed shifting of money around the world to the highest interest rate. Why stop at wine bottles? Try to money will kind of float around, and you try to stabilize those trillions of dollars that are being shifted in split seconds across continents. Economists and scientists, political scientists, have a rich set of work to do here. Or another example, the impact of the clouds. Clouds create intermediaries. Do you remember when everybody was saying that there would be disintermediation? Well, guess what? But on the other hand, these intermediaries can do some useful function. For example, they probably a better and stronger security, but it also lowers privacy and increase surveillance issues. Competition gets you only so far here, and this suggests regulatory approaches and more research on privacy policy. Clouds also improve the protection for IP. Again, the intermediary can do a better job. Similarly, two-way interactive immersive content can have much stronger access control, and all this will reduce the need the intensive focus on this subject by legal scholars. One or two more points, and then I will come to a close. Clouds will also affect negatively the consumer electronics industry because media hardware will move from the home to network-based service, just as phone answering machines did in the past. This affects the need for technical standards. They become much less important, and therefore research on technical standard process becomes less important. Where there will be much more research work, I believe, is in the labor and employment and structure for organizations area. And unfortunately, I am running out of time. So let me just say here, and also the net neutrality and digital device research. Let me then, I could go on, and I have. So let me conclude. There are people who believe that internet research will decline. Decline? Why? Because the internet, the argument goes, suffuses all aspects of the planet, and therefore there will be no such thing as separate internet research anymore, that there is research, social science research on electrification in developed countries. But I think this is not true when it comes to the leading edge or trailing edges. The ultra-fast network will lead to ultra-fast changes in applications and social patterns in a very fundamental way. For policy researchers, therefore, there's a treasure trove of insurmountable problems. We've got plenty of work to do. OII, lead the way.